Welcome back everyone to another lesson. In this lesson, we are going to focus on DHCP version 4. DHCP version 4 means that this is DHCP that is used with IP version 4. First, let's look at some concept of DHCP. So DHCP is Dynamic Host Configuration Protocol. It assigns IP version 4 addresses and other network configuration information dynamically. Because desktop clients typically make up the bulk of network nodes, DHCP version 4 is an extremely useful and time-saving tool for network administrators. Rather than applying IP address manually to each and every host, DHCP saves time by dynamically doing this. A dedicated DHCP version 4 server is scalable and relatively easy to manage. However, in a small branch or SOHO location, SOHO meaning small office home office, a Cisco router can be configured to provide DHCP version 4 services without the need for a dedicated server. Cisco IOS software supports an optional full-featured DHCP version 4 server. So in this example here, the client comes in and then it requests for the service of DHCP. When it requests that, the server, the DHCP server, will reply. But this service provided by the DHCP server can also be provided by the Cisco router. The DHCP version 4 server dynamically assigns or leases an IP version 4 address from a pool of addresses for a limited period of time chosen by the server or until the client no longer needs the address. Clients lease the information from the server for an administratively defined period. Administrators configure DHCP version 4 servers to set the leases to timeout at different intervals. The lease is typically anywhere from 24 hours to a week or more. When the lease expires, the client must ask for another address, although the client is typically reassigned the same address. Now, in a nutshell, you could imagine DHCP to be like they have a bag, and in the bag there are IP addresses. And this bag is labeled with the subnet. When a host comes into the subnet, he will broadcast the need for service. He says, I am new here in this subnet. I need an IP address. So the server who is holding the bag will take out one address and give it to the host and say, would you like this address? And if the host wants it, he will say, yes, I will take that. He will acknowledge that, and then he will start using that address. After he finishes, or if he wants to leave the subnet, then he will then return the address, and that address will be put back into the bag to be used another time. How long does the host get an address is up to the administrator, as we just discussed just now. So it can be 24 hours, it can be a week, it can be more, depending on how you set the lease time in the server. DHCP works in client-server mode. When a client communicates with the DHCP version 4 server, the server assigns or leases an IP version 4 address to the client. The client connects to the network with that leased IP version 4 address until the lease expires. The client must contact the DHCP server periodically to extend the lease. This lease mechanism ensures that clients that move or power off do not keep addresses that they no longer need. When a lease expires, the DHCP server returns the address to the pool where it can be reallocated as necessary. So how does a host obtain a lease? The four-step process for a client to obtain a lease includes: first, it gives out the DHCP discover message. This message is broadcasted, so the client uses a layer 2 and layer 3 broadcast address to find a DHCP server. Once the server gets the information, so he will then reply with a DHCP offer. So DHCP server sends the binding DHCP offer message to the requesting client as a unicast. So when the client wanted to ask for something, it is broadcast. When the server replies, it is unicast. So when the server replies, this is the address I have for you, and I will give it to you. So then DHCP request message will be sent by the client to the server. Now you might think, he just got an address, why does the host need to send requests? Because sometimes in certain networks, there will be more than one DHCP server. So in this case, the client sends back a broadcast DHCP request in response to the server's offer. And once the host replies with the request, the server replies with the acknowledgement with a unicast DHCP acknowledgement message. So this is the four-step process that gets a client an IP address within the DHCP environment. Once you have an IP address and then the lease is up, how does a host renew a lease? So prior to lease expiration, the client begins a two-step process to renew the lease with the DHCPv4 server, as shown in the figure. So here, the client sends a DHCP request unicast to the server because now the client already has an IP address and he can communicate directly with the server. So he says, I would like to renew my lease. And then the server says, okay, and he sends an acknowledgement. And in that way, the client can keep his address. That was a basic concept of DHCPv4. Let's look at how we can configure the server for DHCPv4. A Cisco router running Cisco IOS software can be configured to act as a DHCPv4 server. The Cisco IOS DHCPv4 server assigns and manages IPv4 addresses from specified address pools within the router to the DHCPv4 clients. This address pools, you can imagine it to be the bag that I described before, the bag with all the addresses of the subnet within it. So here we have different hosts connected to the router, and then the router is acting as the DHCPv4 server. So these are the steps to configure a Cisco IOS DHCPv4 server. The first step is to exclude IPv4 addresses. A single address or a range of addresses can be excluded by specifying the low address and high address of the range. Excluded addresses should be those addresses that are assigned to routers, servers, printers, or other devices that have been or will be manually configured. So one thing about exclude IP addresses, you don't want your server IP address to change all the time. So they usually get a manual static IP address. And if they are within the subnet, take those addresses or exclude those addresses from the pool. You can also enter the command multiple times. The command is IP DHCP excluded address, low address, and high address if it is a range. Step 2 is to define a DHCPv4 pool name. Now that you have created the pool or the bag, you have to give that bag or that pool a name so that it is easily identifiable. So the IP DHCP pool name is the command that creates a pool with a specified name and puts the router in DHCPv4 configuration mode, which is identified by the change in the prompt to be router DHCP configuration. Now this prompt tells you that the router is now in the DHCP configuration mode. Step 3 is to configure the DHCPv4 pool. The address pool and default gateway router must be configured. Use the network statement to define the range of available addresses. Use the default router command to define the default gateway router. Use the default router command to define the default gateway router. Now, one thing you have to understand, when you manually configure an IP address on a host, you have to put in the IP address, the subnet mask, and the default gateway. When this is done automatically, these information must be provided, and this is where you set those information. You define the address pool, you define the default router or gateway, you define the DNS server address, you define the domain name, you define the duration of the lease, whether it's days or hours or minutes or infinite. These are the instructions or iOS commands that you use to do all of those. So let's look at an example. This is our topology. So step 1 is to exclude IPv4 addresses. So IP DHCP excluded address, this is a range, lower to higher, from 192.168.10.1 until 192.168.10.9. This range of addresses is excluded. And then we added another one, IP DHCP excluded address 192.168.10.254, and this is a single address. So we have a range and we have a single address. Now one thing here, this excluded address can be done a few times, but be wise about it. The next step is to define the DHCP version 4 pool name. So in this case, IP DHCP pool, and this is the name of the pool that we gave, LAN pool 1. You can be more specific, you can be more generic, but try to be as informational as possible to help you with your administration. Step 3 is to configure the DHCP version 4 pool. Now we have the pool name, we know the addresses we want to exclude, and this is what we have. The network address, network 192.168.10.0, and then the subnet mask. The default router for anyone getting an IP address from this pool is 192.168.10.1. Now see here, the default router is 10.1. Nobody or no other hosts or devices will get that address aside from the router because that address is excluded. Then you set the DNS server, the IP address for the DNS server, you set the domain name, and then the end. So if you have things to configure, configure it here. So now we have created that bag or that pool. We have taken out the addresses we don't want to give out. We have put everything else inside the bag. We have named the bag. We have given the information about things that comes attached to the bag, default gateway, the DNS server, and so on. And it is now ready for the clients to ask for addresses. Once you have configured, of course, verification comes. No configuration is done without verification. And if you're doing something like DHCP, it is more important to do verification to make sure that there is no errors. Use the commands in the table to verify that the Cisco IOS DHCP version 4 server is operational. So you can use show running config. So if you want to focus on the section of DHCP, so you can write show running config section DHCP. So it will display the DHCP version 4 commands configured on the router. Show IP DHCP binding here. This is the command to show you all of the devices that have asked for an IP address and received one. So it will bind the MAC address of the device and the IP address given to them. Show IP DHCP server statistics displays count information regarding the number of DHCP version 4 messages that have been sent and received. So this is an example of the show running config section DHCP. So it will show you all of the commands that you have configured into the router. You can check whether you have done it right. Show IP DHCP binding. You can see that a device with the MAC address 010. So on have asked for an IP address, and this IP address have been given to that device, and it will expire on September 15 at 8:42 a.m. The type of binding is automatic, and the state right now is active, and the interface is connected at gigabit Ethernet 0/0/0. The output of the show IP DHCP server statistic is used to verify that messages are being received or sent by the router. This command displays count information regarding the number of DHCP version 4 messages that have been sent and received. So you can see a lot of information here. Automatic bindings are 2, address pools, there's 1 address pools, and how many messages have gone out or received, etc. Another way to verify that a client has received an IP address is to go to the ipconfig command. The ipconfig/all command when issued on PC1, displays the TCP/IP parameters as shown in the example. Because PC1 was connected to the network segment 192.168.10.0/24, it automatically received a DNS suffix, an IPv4 address, a subnet mask, default gateway, and the DNS server address from that pool. So when PC1 was attached to that and asked for a DHCP service, he was given an IP address, the subnet mask, the default gateway, the DHCP server, and the DNS servers. Remember, these are the ones that you configured in step 3. No DHCP specific router interface configured is required. If a PC is connected to a network segment that has DHCPv4 pool available, the PC can obtain an IPv4 address from the appropriate pool automatically. This makes the life of an administrator very easy. The DHCPv4 service is enabled by default. To disable the service, use the no service DHCP command. To reinstate the service, use the service DHCP command. So this is an example to shut it down and to put it back up. Enabling the service has no effect if the parameters are not configured. So you have to configure the parameters like the excluded, the pool name, the configuration, and information about the pool. Clearing the DHCP bindings or stopping and restarting the DHCP service may result in duplicate IP addresses being temporarily assigned on the network. In a network, a subnet doesn't stand alone. It has to be able to communicate with other subnets outside of its own. So in this case, you need to have a relay. Let's look at this example. In a complex hierarchical network, enterprise servers are usually located centrally. These servers may provide DHCP, DNS, TFTP, and FTP services for the network. Network clients are not typically on the same subnet as those servers. In order to locate the servers and receive services, clients often use broadcast messages. Let's look at the figure. In this case, we have a DHCPv4 server. The router is not doing this DHCP service. So PC1 is attempting to acquire or to get an IPv4 address from the DHCPv4 server using a broadcast message. PC1 is broadcasting that it needs the service, but this is a router. One of the router features is that it does not forward broadcast. Now we are in a problem. Because the DHCP server is located on a different network, PC1 cannot receive an IP address using DHCP. So R1 must be configured to relay the DHCPv4 messages to the server. So R1 is a router. Router do not forward broadcasts, but we have to configure it to say just forward the broadcast for DHCP. So how do we make R1 forward or relay the broadcast? So we can configure R1 with the IP helper address interface configuration command. This will cause R1 to relay or to forward DHCPv4 broadcast to the DHCP server. As shown in the example, in R1, the interface that is connected to the PC side or the subnet side, we configure the command IP helper address 192.168.11.6. This IP address is the IP address of the DHCP server. So what is happening here is we are telling the router that if you get a broadcast for this particular address, send it forward. Others you can stop, but if it is for this particular address, send it forward. The show IP interface G000 command can verify this configuration. So if you type this one in, you would see that it is up, it has the IP address, it has the broadcast address, and it is also a helper address, meaning that it is helping this particular address and it will relay the broadcast destined for this particular address. So that is how we configure the server. Let's look at how we are going to configure the client side. There are scenarios where you might have access to a DHCP server through the ISP. In these instances, you can configure a Cisco router as a DHCP version 4 client. Sometimes, Cisco routers in SOHOs or branch sites have to be configured as DHCP version 4 clients in a similar manner to client computers. The method used depends on the ISP. However, in the simplest configuration, the Ethernet interface is used to connect to a cable or a DSL modem. To configure an Ethernet interface as a DHCP client, you use the IP address DHCP interface configuration mode command. In this example, let's assume that the ISP has been configured to provide select customers with IP addresses from the range 209.165.201.0/27 after the G001 interface is configured with the IP address DHCP command. To configure an Ethernet interface as a DHCP client, use the IP address DHCP interface configuration command. The configuration assumes that the ISP has been configured to provide select customers with IP version 4 address information. So in the SOHO router, in interface G001 that is connected to the ISP, we type IP address DHCP, no shutdown. Once you do that, and if all the other configurations on the ISP is done, you would receive this message from the router. It has been assigned an address, interface Gigabit Ethernet 001 assigns DHCP address 209.165.201.12 with the subnet mask, and the host name is SOHO. We can verify this by show IP interface command, and we would see that yes, in fact, that this particular interface has been given that IP address with the subnet mask and the broadcast address, and the address has been determined by DHCP. So that is the end of DHCP version 4. We have looked at a little bit of concept, we have looked at configuration, and we have looked at some troubleshooting. So until the next lesson, goodbye.